Hi everyone, this is Steven, host of Computer Art Explorers. Welcome to another exciting episode of exploring how to create computer-generated art. Computer Art Explorers is both a YouTube channel and a meetup group. Today, we're going to discuss all of the source code used to make dancing roses. You can download a zip folder which contains all of this source code. Simply use the link posted in the description of this YouTube video. Before we get started, we do want to mention that for the best viewing experience, please watch this video on a monitor having a resolution of 1920 by 1080 or higher. And you want to watch this video in full screen mode. Also, make sure that your YouTube settings are for high definition 1080. All the code, all the lessons, everything we're going to teach in this video is we're going to explain everything that creates this image of these two roses that are dancing on the screen. And the lessons you learn, you're going to be able to apply these to all kinds of computer art that you want to be able to create. Okay, so what we have right here is we have the folder that you can download on the internet. So I'm going to go ahead and click it and open it up, and notice everything that's in here. Now this happens to be the same folder that you guys can actually download. Of course, what you download will be in a zip folder. You'll have to extract that out, put it on your desktop. The only thing I did different was I just changed the icon on it so you have this pretty icon for the video itself. Now, let's take a look at the files inside of this folder. You have 5 source code files, all right? And I'm going to click on this one, right click on it, come down to properties, and you'll notice what we have here. It says under type of file, it is a Sybos source code file. It's a .cb code file. Now, if it doesn't say that on your computer, that means you have not installed Sybos yet. So if you haven't installed Sybos, we have another video that talks about how to download and install that. It is freeware, so just go ahead and look at that video, go through that process if you want to follow this, and you can actually do everything that we're doing on this video. You can do this on your own Windows laptop or desktop computer. So let's go ahead and open this up. And so what you're looking at right here is the master source code file. Now, a master source code file, it's a special file. It lists all the other files that are going to comprise a single project. Now, one project will compile into a single application program. And the whole purpose of this is that you could have all of your source code in one massive file, but it'd be very difficult to work with, especially as programs get longer and longer. It's a whole lot easier to take chunks of code. For example, this right here, it says load and make images. So there's a chunk of code that's all it does is load and make images, and we take all of that code and put it in a single file. So we can open up that file, work with it, and then when we're done with it, we can put a read-only flag on it so we don't accidentally mess it up, and then just call it and use that code when we need it. But otherwise, we don't have to look at it on the screen unless we're actually focused on that particular thing. So by being able to spread all of your source code in a single application that you're going to create across multiple files makes it a whole lot easier to actually create and develop applications. So let's talk about how this actually works. And there is this super meta command right here, the create project super meta command. And that's what actually, having this command here is what defines this file as a master source code file. The fact that this is just a label line and we have text here that's saying that's what it is, that's just comments or documentation in the file. We could take that line out and it's not going to change it. What matters is that we're using the super meta command, create project. Now what I'm going to do is I'm going to go ahead and hit Control Shift and double click on it and open this up so you can see it. And so there are some related commands, and these are called super meta commands because super meta commands are special commands that tell the Sybos application developer to do something. And if you notice, that's the reason why super meta commands generate these gray zone buttons, because it's telling the developer to create this special label line. So instead of looking at text, when the super meta command is activated, it's telling the Sybase application developer that we want it to display these lines, or in this case, display a line and center this text in it. All right. Well, this super meta command, the create project, what that does is, notice the name of the project. We have named it dancing_roses. Okay, so see, this is red. This little button here, this gray zone button, is red. Red because this project has not been built yet. So I'm going to click on this and show you what happens when you build a project and what a building project means. What it means is you're telling the application developer, hey, I want to build this project, and it reads all of the source code files that get included in the project and builds you a file tree. And the reason it does this and why you want the file tree is so that when you're working in your project, you can easily switch between the files in the project. Okay, so for example, if we want to go over to the captain right here, this file, the file name that's b01-captain.cb code, that file just got loaded in because I clicked on this right here. If I go back and I click on this, it's going to reload in the master source code file. So that's the whole reason why you want to build projects and you want to use this create project super meta command. Now let's go back to Captain and let's take a look at the super meta command that is being used here. This command is part of project, and it's basically declaring that this particular file is a part of the project known as Dancing Roses. And that's important because I'm going to go ahead and close this out. If you were to open up, just say the Captain, the Sybase application developer, which is like a text editor and provides you all this neat reference material, it's not going to know what other files are associated with this project unless you have this meta command in here. And so this meta command is telling the developer that, hey, this file happens to be a part of the Dancing Roses project. And so what the application developer does is it goes into the Windows registries where all the project information is saved, and it reads basically this file tree information. Going back to the master source code file, we also have another super meta command called the project folder. So if you notice here, what we've done is we've put all these in individual folders. Now this is not a folder that exists on the directory structure, okay? But this is rather a folder right here so that you can group a bunch of different source code files together into a folder in this tree. So therefore this project folder refers to the file tree structure here, not folders on your disk drive. All right, these are like here at images, this is a folder on your disk drive. So I just wanted to point that out, that actually what you have here is you have all of these files are in the same folder on the disk drive. But again, going back, this folder is just a file tree folder. So there's a difference between a project folder and a disk drive folder. Really wanted to point that out so you guys don't get confused. Okay, now before we go any further in talking about the actual code for the Dancing Roses program, I'm going to close this out and open up a new file. We're going to start creating a new program simply to teach a couple of lessons because this is beginner level. So I'm going to go up and hit the new, and here we go. Now, one thing all new programmers need to understand is something called program flow. The Captain subprogram is the first subprogram that will run. The very first line of the Captain subprogram is the first line of execution. That's where your program flow starts and it goes down. When the program flow hits the end of this, what's called the end of subprogram or the end sub command, when it hits that, your program terminates. That's the end of it. Okay. So what we're going to do is first I'm going to just go ahead and run this so that you can see. So it cleared the screen, printed hello world, and then the program ended. And when it ended, it turned the border red to indicate to you that the program has terminated. So what we'd like to do is show you guys how to create another different type of subprogram. So I'm just going to copy this down, and I'm going to create a subprogram called Zoom. And you do not have to have the headline. Again, this is all documentation. I'll get F12 to see this. All of this is just documentation. Doesn't have to exist, but it's nice to, it makes it easy to find the beginning of a subprogram. It also makes it easy to snap a version number on there and have the date every time you make changes to it. Here, this is a different subprogram, and the way we execute the code in here, I'll go ahead and type in some code. Let's say just print a bunch of $signs, okay? And if you notice, I'm going to go ahead and compile and run this again, and that Zoom subprogram never got executed, and that's because it wasn't called. The program flow started, went CLS, print hello world, came down, hit end sub, and that's it. The program ended. If you actually want to execute the code in this subprogram, you have to call it. And to do that, use the call command. And so we're going to call, and then I'm just going to go ahead and copy this up here. And I'm going to go ahead and compile and run it again. Now you can see it got called. So you have hello world and you have the $signs. So what happens is the program flow comes down, hits this, calls to Zoom, it starts here, follows all the way down. When the program flow hits end sub, the program flow comes back up to the next instruction after the Zoom. That could be the next line, or if you have a colon, okay, you could say print, and I'll just put a bunch of dots, maybe something just so you can see it. And then it'll come down and just print done. Okay. So I'll go ahead and compile and run that. And so what you can see has happened is it's printed the $signs, the dots, and then done. All right, just like that. So hello world, came down to Zoom, printed the $signs, ended, came back up, then did this instruction, then did this. We could call Zoom again. All right, so and compile and run it. And so you can see it's happened. It's printed the $signs twice. And that's because every time you call it, it's going to execute this entire subprogram, and then when it hits the end sub, it's going to come back. Okay, now before we go back and take a look at the Dancing Roses code, we need to go through a couple more things at this beginner level. And the first thing we need to talk about is variables. Variables hold data. I'm going to click on this here, this bookmark, and it's going to bring this up in the manual, and it's going to talk about data types. Now, the Sybos programming language has 4 data types, an integer variable, a float variable, a string, and a limited use, what's called an int64 type. And we're not going to really talk about that. That's used on huge files over 2 gig. But there's 3 main data types that you're going to be using all the time. All right. An integer variable, that's simply a whole number that is minus 2 billion in this to positive 2 billion in this. All right. It does take 4 bytes in memory to hold an integer, and this is also known as a 32-bit integer. All right. If you want to declare an integer, the variable name must end in this % sign. So you notice here I have x equals 5. Well, of a floating point variable, it is actually what's called 64-bit floating point precision. So you can represent a number in this range. I'm not going to say this, but it's a huge range of numbers as a floating point number. If you don't have that % sign after the variable name, for example, if I had the % sign there, then that would be declaring x. It would be, the way we would say that is, this is an x integer variable versus just an x variable. All right. So to make it easy, I'm just going to use x. So here we have x equals 5, and then you can also have what's called a string variable, and a string variable just holds string data. And let's say this hello world. All right. We could have a string equals, and we could put this string of text, assign it to a string, and then we could print the value of a string. And I'm just going to do this and then hit pause so that you guys can see it. And what happens is the hello world is printed because that is what's been put into a string. And you can do something called string concatenation, where you can have a string, you can have b string, and I'm just going to put just a bunch of garbage just so you can see it. And let's say I want to print C string, and I want to declare C string is equal to A string plus B string. And this is called string concatenation. And what it's going to do, it's going to assign first hello world to C string, and then it's going to tack on or concatenate what B string is equal to onto the end. So, and then it's going to print it. And just to show you that, see how it did that. Okay, those are what's called string variables. And if we go back to our data types, it will tell you here what a string variable has the following characteristics. It's a variable name that ends with the $sign character. Okay, so these are the only 3 data types in Sybos that you're going to use almost always. Right? Again, we're not going to talk about this int64 type. Very, very limited use, only with huge files. So at a beginner level, you don't even need to think about it. Okay, you're not going to worry about it. These are just the only data types you need to worry about is integers, floating point, and strings, which makes this language extremely easy to use. There's other languages that literally you have thousands of data types, and they like C++, which is why those languages are not beginner level. And you really want to learn, if you're going to get into, let's say, a programming career and you're a high school student or a college student, you want to learn an easy language first, a beginner level language. Sybos is such a language. This is a perfect language to be your first language because this is classic basic syntax. It goes back, this language was originally invented back in the 60s. You can read about it on Google. Just type in basic and history of basic programming language or classic basic, and it will describe to you who actually invented it and whatnot. Sybos it uses the syntax, the basic syntax of classic basic, but other than that, it is a separate language because it is written for modern day Windows computers, and it has all of these other commands in it that drive the Windows environment. Okay, and that's why this Sybos is a unique language and a very powerful one at that. It's got all kinds of other commands in it that we'll get into in some other videos, and a huge manual that's built in. So if you compare Sybos to the old languages, it has the positive aspects of it's very simple and easy to learn, and it also combines the power of modern day computing with the Windows environment. So you get the best of both worlds with this particular language. Another reason that's why we're using it. So we're going to go ahead and I'm going to get out of the strings. I'm going to go back and I'm going to talk about the data types one more time just to show you that this X variable being a floating point, it can hold a number that has a range of this range here. So you're talking about 1.7, if you remember this from high school math, e to the plus minus 308, which is like 15 digits of precision, with 15 digits of precision. So it's going to hold the value of 5 real easy and a whole lot of other numbers. But we're going to assign that number to X, okay? And then we're going to print it. And then we're going to end, and the program is going to end. So I'm going to show you this, and let's go ahead and run it. It shows you, and I have that in there capped, and just so that you know that this print statement is the command that's being executed here, it's showing you the value of X within the captain subprogram. Now here's why this is very, very important. Let's call our zoom subprogram, which we are going to print down here, zoom, so that you know that when we print the value of X, it's being printed within our zoom program. And I'm going to go ahead and run the program again. And what happens is you notice that there's a difference here. X is equal to 0 within zoom. All right, and you're thinking, well, why is that? We assigned X the value of 5. Now, this is why. The global versus local variables. So All global variables are global to all subprograms, and local variables are local to a single subprogram. So the sub defines a subprogram. This keyword right here, sub, means that this is going to be a subprogram, and everything within here, all local variables are local to this subprogram. All local variables in the Zoom subprogram are local to Zoom. Okay, and if you're wondering, well, how come it was 0 and not some other weird number if we didn't? Because we didn't assign it a value. In the Sybos programming languages, all variables that are used within the language, until you assign them a value, they start out at 0. So you never have to worry about resetting a variable to 0. It always starts at 0. It can never start at something else. So you don't have to worry about initializing something to 0. In other languages you do, and that's why I bring this up. Why is this a local variable? Now this is very, very important. We're going to go over here to what's called the first two characters. If the first character is lowercase, it is a local variable, right? So here you have an example, AB, A1, A underscore. All of these start with a lowercase a. It's starting with a lowercase letter. That means it is a local variable. And that's what defines this as a local variable, the fact that the x is lowercase. If we change that to an uppercase x, it will all of a sudden become a global variable. So let's just go ahead and do that and then rerun it. And you can see that in the Zoom subprogram, the value of x is now 5. That's because it was assigned up here. All right. It also means that if we were to change this, x equals 3, for example, okay, now watch what happens. This is the first time we're going to print out the value of x, then we're going to call Zoom, and then we're going to print out the value of x in Captain. And let's watch what happens. So you can see in Captain, the value of x is 5, then it got changed to 3 in Zoom, got printed, and when it came back to Captain, it was 3. That's because this is a global variable, which means any subprogram can change the value of it, can access the value of it, and change the value of it. Very, very, very important concept. But if it's a local variable, all right, just to show you guys that all that matters is the whole rest of the variable name can be capitals. It doesn't matter. The only thing that matters is what it starts with. I'm changing it there so it prints on the screen properly. Okay? And I'm also going to change x factor here to 3. So there we go. So let's just go ahead and run this so that you can see what happens. So notice the Captain x factor is 5, the Zoom x factor is 3, but we come back to Captain and it's still 5. And that's because it got set to 5, it stayed 5, we called Zoom. Zoom cannot affect the local variable that is in Captain. And so that's the reason why it stayed here. All right, let's go ahead and go back into this Captain of the Dancing Roses program. So here's the Captain subprogram. The program flow is going to start here. It's going to come down. It's going to hit call, load, and make images. So let's take a look at that code. I'm going to come over here, open this up. We're now looking at the file, load and make images. And in this file, we happen to have this subprogram. And the first command here is embed resource file. Now this is a meta command. A meta command is a compiler directive. It's telling the compiler to do something. So I'm going to go through this in the index. All right, and I'm going to show you guys something. And that is, if a command starts with a double pound sign and ends in a double pound sign, that is a super meta command. So up here, where you have the part of project, a super meta command is a directive for the application developer. It tells the application developer to do something. For example, we want to have a label line, okay? Where you can click on, like on here in the version one, you can click on that and increase the version. So these are commands that are being read by the application developer and the compiler, and when your program runs, it doesn't do anything. Okay, once your program is compiled into an executing program, the super meta commands aren't even in there, right? The next thing is your regular meta commands. These are your compiler directives. So I'm going to open this up, and what you're looking at right here is, and there's a lot of them, okay, but you're looking at all of your regular meta commands, and each one of them tells the compiler to do something. So if we actually look at this embed resource file, and I'll go ahead and click on it to open it up. That's I was holding Control Shift and double click the mouse, and it opened this up. It tells you about it here. Of course, you can always view it in the manual where it'll give you all the information. It'll talk about the concepts and the purpose, but I'm going to go ahead and go through those so you don't have to look at it there. And what this is actually doing is it's taking this image, all right, the mountains, and it's a bitmap file, .bmp, and then the next one is doing it with the rows, BMP. So let's take a quick look at these files. And again, it's in the image subfolder. So here we go up to images, that's a subfolder, and here's your mountains. So this just opened it up in a paint program, so I'm actually viewing the bitmap image in the paint program, or I'm going to do this with rows, and I'm viewing this one in the paint program. So notice that's the rows that we're actually using. That's the original graphic for the rows that's being painted on the screen. So let's go back in and take a look at that, and let's see how that's working. Okay, so the next thing to talk about is what exactly we're doing with this embedded resource file. So this compiler directive is embedding that entire image, the mountain image, into the actual code itself, and it's generating this resource pointer. Now this resource pointer is going to point to that image in the code, and this next command, open graphic region using resource, it's going to create a graphic region in memory that we can do stuff with. All right, we can define rectangles in, and we can print them on the screen. And it's going to assign that to the GR mountains. Now, GR mountains, this is a floating point variable. And all we're doing is we're assigning a number to this variable. Now, let's go ahead and take a look at this open graphic region using command. Technically, it's a function because it returns a value. But let's go ahead and take a look at this. And notice here in the syntax over here, it's telling you that this function returns an integer. Now you can assign an integer to a floating point because a floating point variable can hold every possible integer. We're just going to take whatever it returns and put it in this variable here. And what I'm going to do is just to show you what it's doing is I'm going to print, and then I'm going to pause. And I'm going to run it. And so what you have is the variable GR mountains is being set equal to 1, and the variable GR rows L is being set equal to 2. And because it's a capital G, these are global variables, which means we're going to be able to use these other places. So what's going on here is that this command is opening a graphic region in memory, and it says it is returning, so notice here the integer, the out integer. Well, what is this? It's a graphic region handle. And what does a handle mean? It just means that in other commands that you can specify that this is the graphic region I want to use. For example, let's say we wanted to place this graphic region. And here's your parameters, the graphic region handle. So I'm just going to go ahead and place the rows. Then we're going to have the column number and the line number. So I'm going to just say put it at 3, 3. All right. Now let's go ahead and run this so you guys can take a look at it. So what it's done, and again remember, here's our grid snap, and if I put the cursor right there, we're at column 3, line 3. And if you look right down here, when I have the cursor up there, you can see where it says 3 by 3. So that was the column and line that got placed at. See this GR rows L equals 2? Well, we could instead of using that, just put 2, because it happens to be graphic region number 2, and it's going to do the same thing. But you're never going to be able to keep track of that. That's the reason why we're using a variable to remember the value of the graphic region that got used. Okay, and I'm explaining this at this level because this is for beginners, and I want the beginners to understand how this works. That's all it's doing is when it's passing this information in, it's passing in a number that references to the graphic region that was opened. And notice it happened to be the second graphic region opened, and that's the reason why it's number 2. We could close that graphic region out and then open another one, and then number 2 could get assigned to a different one. So you always want to use a variable to represent a handle. Now I'm going to go ahead and take this out, and let's move down. So far, this is loaded images in. It's embedded the images into the source code, and then it has opened up a graphic region with each one of these images in it. Coming down to make images, let's go ahead and run this. I'm going to show you guys something. I want you to pay attention to something. Notice that these roses always face each other, okay? At a certain point, they'll flip, all right? And I'll make it go a little bit faster so you can see, okay? As they pass each other, I have them flipping so that they're always facing each other. Now the way that is accomplished is, initial image is a left-facing rows. So I have graphic region rows L. L just simply means left-facing, okay? And this is a variable name. I just decided to call it L. You can call it whatever you want. I could have called it, I could have actually said left, but I'd have to change that everywhere in the code, okay? Because that would be a different variable, all right? And variables, by the way, are case sensitive. So that variable is actually different than this variable here, where I have uppercase the S. These are 2 different variables. Moving down, what I'm going to say is define the source rectangle as this graphic region. What this command lets you do, it lets you define a source rectangle as any rectangle within a region. And if you look at this, and notice where it says over here, define source rectangle as, it means the entire thing. So the equivalent to this is, if we go into and bring this into a paint program, for example. All right, I'm going to hit Control A in the paint program, and if you notice that the border changed when I did that. And if I were to copy this and hit Control C, it's defining this entire thing. The Control A can define this entire thing as the source rectangle, and I hit Control C, it copies the entire thing. Then I could actually come and open up another painting program. So you can see it, I hit Control Paste, and there's the image. I could then paste it again and image again, okay? What if I wanted something smaller? Let's say I wanted just to have, just a centerpiece like this. And notice what I'm defining here. I'm saying, well, this is the rectangle I want to use, all right? Well, this rectangle is going to have, at the pixel level, this rectangle is going to start at an X value of right here, whatever that happens to be, 80 or 90, I don't know, and a Y value, again, 80 or 90. It's going to have a width and a height, okay? So in a paint program, I just, you can just snap on, and then I can hit Control C to copy it to the clipboard, and then I can go back in and paste that in something else. Let's say something over here, all right? So that's the concept. Let's go back into our code, and you can do the same thing programmatically with, we're defining a source, or you can define a target. The command that defines source rectangle as, it means the entire graphic region, all right? The entire image that we loaded in is what I want to define as my source rectangle. Now, this next command, open graphic region using, I'm going to click on that so you can see that. And what this is doing here, under int1, it says you can use one of these flags, all right? So we can open this region using a source rectangle or a target rectangle. It has to be defined though, all right? And we could open it up and we could rotate it 90 degrees. The CCW means counterclockwise, or CW clockwise, all right? So do we want to rotate it? But we don't want to rotate it. What we want to do is just create a duplicate image initially, all right? So this command, by defining the source rectangle as the entire thing, then this command right here, creating the graphic region, is going to create a duplicate. Then the next thing we're going to do is say define a target as the entire thing and flip the target horizontally. So what this code does is it creates a graphic region that has a right-facing rows. So I'm going to go ahead and go back to the captain, and let's look at the next thing we're doing. It says let's call this open display shield. So I'll click on this. Okay, so taking a look at this code here that has the subprogram of the open display shield. First thing we're going to do is take a look at primary display boundary. Because under Windows you can actually attach multiple displays to a computer, or several monitors you can hang off of a computer, and you can configure them differently. What you have, I'm going to go ahead and take you over to this right here. It's going to show you that if you have one monitor, you're going to have a virtual display that just is that monitor. But if you have multiple monitors, you're going to have a virtual display that's going to span two or more monitors. And the coordinate system is on the virtual display. A virtual means it's all your monitors plugged together. And you know, in Windows operating system will let you take, like, if you have multiple monitors, it'll let you arrange these things any way you want. The idea is that you arrange the monitors to match the physical way you have the monitor set up in front of you, so that as you move the mouse around from monitor to monitor, it tracks. So what this does, get the display, the primary display boundary is for the primary monitor, which is always monitor number 1. It's going to return what the left boundary and the top boundary is. All right, so if we only have one monitor attached to the screen, it's always going to be 0, 0. Okay, the left side is always going to be 0, the top is always going to be 0. But the width and the height are going to change depending on what kind of monitor you have. In this situation, I'm going to go to the control panel, click on screen resolution, and you can see here we actually have two displays. One display is in the video mixer that's attached to this computer, and then the other display happens to be the display that I'm looking at as I'm creating this video. And these two displays are duplicated, and that's the reason why it says 1 and 2. But the most important thing here is the fact that it's showing a resolution of 1920 by 1080. So if we go back into the code and we look at it, this get primary display boundary, what this is doing is this is going to set up these screen boundary variables, and it's all these variables right here, the width and the height. These variables here are going to get set up by this command. All right, that's the most important thing you can understand about what's going on here in this code, is that this command, the output of this command is going to all the screen boundary variables, which are all of these variables here. So these variables are being set up, and then what I'm doing is I'm saying, okay, I'm going to assign that to a global variable that I'm going to call DS. VD means virtual display, the X position, the Y position, the width, and the height. So at the beginner level, all you really need to know is that the DS wide and the DS high, that is going to simply be the width and the height of in pixels of the primary display monitor. And then the center point on the center X and the center Y, the very center point of the screen, it's going to have the X and Y coordinates of that, because we're taking the width divided by 2, taking the height divided by 2, and that's going to compute these values. The next thing we're going to do is what's going to be called open a display shield. So I'm going to go ahead and come down here, and I'm going to pause this so that you guys can see what's going on. I have to take the read only off so they can make changes to this file. Hit the pause, and let's just go ahead and run this to see what happens, okay? Just so you can see what happens. And it ran it and hit pause. And notice what you see here, okay? You see, all you see on the screen is the mountains. And again, remember this red HD, that's being stuck on by the video mixer, All right, so that has nothing to do with our program. You run this, you're not going to see that, but just so you know, that's the reason why that's there. So I'm going to hit escape to go past that pause, and then it's going to run the program, which is putting the roses on. I hit escape again to exit the program. Now let's say that the display shield, just so you guys can see what's going on, I'm going to divide this by 2, and I'm also going to divide the height by 2. All right, and then I'm going to rerun it. And notice what's happened. Okay, the width has been cut in half and the height has been cut in half. And it's still starting to display at 0, 0. All right, but also want to show you is notice how other windows are floating underneath of our display shield. Now what the display shield is, it's simply a window that doesn't have an edge on it, and it's also what's called a topmost window. All right, so that's the reason why these other windows are floating under it. Even though like this window has keyboard focus, it's floating underneath of this window. And that's because this has been defined as what's called a topmost window in Windows operating system. All right, calls it a topmost window. So let's go ahead and go past, and I'm going to kick this out a little bit so that you guys can see what happens. I'm going to add 100 and 100. And I'm going to redo it again, and you can see where I've kicked the starting point down. The width and the height is still half of the screen, but I've kicked it out some so that we can go all the way around it and you can kind of see what's going on. Okay, I'm going to go ahead and run this again, and you can see how the roses, when they go off, they get cut off. Nothing gets extended up, and that's because we've defined a display shield. And a display shield is an edgeless window that we can paint pixels all the way to the edge. Now you compare that to, let's say, the window here. All right, notice when I take my cursor and I go onto this, this is called a sizing frame. All right, on this particular window right here, I can grab a hold of it. It makes this, see how the arrow turns into like a horizontal double arrow? I can click on the mouse and I can size it. That's because this has a frame on this particular window. The display shield is simply it's a borderless window that you can paint onto. Right? That's the reason why we use it for graphics. And it's high-speed graphics, as opposed to a runtime window. As a matter of fact, I'm going to go back and show you guys something. So what I'm going to do is I'm just going to place this on here, and there's a very specific reason I'm doing this. And I also am going to cut this down to thirds to make it a little bit smaller. So watch what happens when I do this. Here we've got the display shield, right? It's now a third of the screen wide and a third of the screen high. And we also have this rose being painted inside of our runtime window. I'm going to bring up the calculator because the calculator lets you show you what's going on here. Notice as I take the calculator and I drag the calculator across, the rose is being repainted. It's being destroyed. The image is being destroyed as the calculator goes across it and wipes it out, but the runtime window is maintaining this image, all right, because it's detecting the fact it's being destroyed and it's repainting it. Now, the calculator is floating underneath the display shield because the display shield is a topmost window. But I want to show you guys the fact that there are windows that can destroy this. All right, hit Alt-Control-Delete, and I'm going to go into the Task Manager. This is the Task Manager right here. So the Task Manager floats over top. So let me go ahead and rerun this now that I got that out, and I'll show you. So your normal windows, like the calculator program, other programs, word processors, if you had Notepad up, other windows are going to float underneath of this because it's defined as a topmost program. But the Windows operating system allows programs such as the Task Manager to supersede, and they are like, it rides over top, and look what happens. See how it's destroying the image, but the image is not being recreated? and all you see is black. Now the window's still there. I mean, you can still see it. The calculator's still floating underneath of it, but it's not being repainted. And that's because on the display shield there is no maintenance. If you want to maintain the image, your program has to maintain it. Here, the runtime window, this image is being maintained every time it gets destroyed or messed up. It's being maintained by the Sybos runtime engine that's running your program. So, but it takes a lot of compute cycles and a lot of overhead to do all that maintenance. So if you were trying to do high-speed graphics inside of a runtime window, it's going to go really, really slow. You're going to see it's going to be really bogged down. That's the reason why we're using this display shield, and we're not worrying about it being destroyed because we're assuming that the user is going to go like this. Now what's really interesting, watch this. I'm going to go ahead and hit, notice the program is paused, right? Because of the yellow border. I'm going to go ahead and hit the escape, and here you have the roses being painted on. So that's because we painted the background, right? We painted the background of the screen, and then we just start painting roses on top of the background, and we're not maintaining the background. There is a way to detect that, hey, there was damage done to this image. So there's a way that your program can detect it. We're not going to get into that in this video, but there's a way to detect it so that you can maintain that image. But I'm showing you this so that you know that you, in fact, have to maintain the image. So let's move on. This right here is opening the display shield. So this is, let's look at this command that actually opens this up. Changing the color real quick. The command ahead of it here, changing the display shield color to 0. 0 is simply black, okay? You could also say color black, so 0. You can go in, you can look at that, and you're defining black, or you could say orange. And you guys can look at these commands later, but just to show you that if you did that and then paused it, just so you would see what would happen, all right, notice how the display shield is orange. And that's because we changed the color of the display shield before we open it up to 0. That's going to be our base color that we want to open it up. We're opening it up, and if we look at this command here, it says, okay, we're opening a display shield, and we're going to give it the X coordinate, the Y coordinate. So we're passing in these variables, and up here we defined them. And we went to the left boundary, and we said, well, let's throw 100 on. Right? Here's the Y value. So you get the X value, the Y value, X, Y. That matches up with the X coordinate on the virtual display, the Y coordinate on the virtual display. So if you had multiple monitors, right? Remember, go back up to here. If you say, well, hey, you know, I got multiple monitors, and let's try this again. I want it to show up on the other monitor, all right? Well, if you got multiple monitors, there are commands that you can actually go and get the virtual display boundaries for the other monitors. Now, again, that is going to be outside the scope of this video, but I want to point out the fact that you can do that. So if you have a situation like this here, there's a way for you programmatically to detect how many monitors are attached to the computer and to get the coordinates for each one of those monitors. Right? You will be able to do that, so you can then create display shields or windows, and you can do anything and everything you can imagine as far as placing stuff on different monitors. It's really cool. You can get creative and do all kinds of neat things. The N3 and N4, that is your width and your height, and I'm not going to describe this other command. It gives you a couple of other variables you can change. We're not going to get into that, again, beyond the scope of this video. So here we go. We've defined the display shield color, then we've opened up the display shield. Let's go ahead and rerun this. Copied this image of the mountain image onto it, and the way it did that is it defined the source rectangle as the entire image of the mountains. Now remember, that's a huge image, right? And then it defined the target rectangle as the entire display shield. And then it copied using stretching. And when using stretching, it can either stretch it bigger or stretch it smaller, which is actually compressing, but it just stretches the image to fit. So it stretches whatever's in the source rectangle to fit the target rectangle. I'm going to click on copy rectangle so you can see the different options you have. Let's say if we just use the target dimensions versus this stretching, watch what happens. Start it back up again. Okay, notice how you only have the upper part of that image. You don't have the whole mountain range in there because that was just the little upper piece of the image. Divide this by 2 just to see it a little bit differently. Okay, so you can see more of it, but if you actually want to take the entire image and have it resized into the target rectangle or your entire display shield, you have to use that stretching. So you have to go back. Notice I'm going to come over here and pick that. In fact, yes, I want to hit the use stretching. I copy it to the clipboard. I come over here, I double click on that to highlight it, and then I hit Control V, and that removes the old and sticks in the new. So I pointed that out because it's really, really easy to change stuff in this editor. You just have to learn the controls and learn how to use it. So let's go ahead and get rid of these 2 lines here, and let's change this back to what it originally is. All right, and then I'll rerun it to make sure we're not missing anything. Let's change this back just so nothing else is different. All right, so I can compile and run it, take a look. Okay, and this is the program that we started with. All right, and I can even go and hit the read only to put the read only back on. Then let's go back to our Captain program. Okay, now moving on, we're going to talk about this next section is the setup and control variable section. And we've got a couple of variables here. We're defining the row's base size as 250 pixels. This is just what we decided we want to start as a midpoint size, and then we want to vary from that size plus and minus, and in this case 200. So you can actually change these values and see what the effect is. What this variation means is if it's minus 200, it's going to be the base size 250 minus 200 is going to give us 50 pixels, right, wide by high. So you're going to have a rows at the smallest, it's going to be 50 by 50, and then your largest image would be 450 by 450 because it'd be 250 plus 200. So that's what you're looking at, right? That these settings are going to generate a rows that's 50 by 50 up through 450 by 450. Now, I am going to hit the just like that to make a remark, just so you guys know. In some languages like C, C++, if you use a double slash, it turns it into a remark. It means anything after is a remark. So if you notice the blue type, it's slanted or in italics. That's indicator to you that is a comment or a remark that's in the code. It lets you document your code without actually affecting the program itself. Sybos allows you to use an apostrophe to do the same thing. So your choice. And by the way, just to cover this, notice how we're using the dash. A dash, same thing. Okay, if a line starts, if the first character on a line is a minus sign or a dash, same character, right? It means that the rest of the line is, in fact, a remark. Okay, so I want to show you guys information about the remarks. Because I don't remember where this is at in the manual. I went over to section 16, came down here to the subject matter under the language syntax, and skipped down here. Notice comments, remarks, and that's over in section 32, page 7. So I'm going to come over here and just show you this. Click on section 32, page 7, and it takes us right there. So notice here's all your page numbers and your sections. So documenting with remarks, and this tells you the first character is a remark indicator. So here's where it's listed. It tells you can use the double slash or the apostrophe, and it also talks about the fact that if you have the asterisk or the dash slash minus sign or the double dash or what's known as the equal sign, if the first character on a line starts with any of those, right, means it's a remark indicator. So the whole reason why you can start a line with a dash is so that you can have a line of dashes to separate code, and a double dash or an equal sign, same thing. All right, so this is just syntax specific to Sybos, and it is very, very nice. And if you notice the way I use it, it lets you, like for example, it lets you group all of this stuff, and it's a nice, easy way to have your eyes be able to just kind of focus on code, and it makes creating clean, well-documented code really, really easy to do. That is critical. If you're going to create great, big, long projects, the better documented your code is, the easier it's going to be for you to revisit that code 2, 3, 4, 5 years from now if you want to go back into it, make changes to it, or copy pieces out and use it for something else. You don't have to rethink the whole process if you have it well documented. So let's go ahead and move on. Looking at the fact that the base size and the size variation with these settings is going to create this variation, 50 by 50 to 450 by 450. Let's run that and take a look at it. Okay, and I'm going to go speed it up. So there you go. At the biggest it was 450, at the smallest it was 50. All right, so you can kind of see that if you want to change that, the size of these roses or on the variation, that's what you can do. Also notice that as the roses get smaller, the user perceives the rows to be further away, and that's how you get this three-dimensional effect, by having the rows change and get bigger and smaller, and it looks like it's whipping around three-dimensionally on this image. All right. The speed control, so I have an initial setting of 1, and then this here, if we move down in our code, this says process user input. So what we're doing is we're letting the user press keys on the keyboard, and then the keys are going to do certain things. This command in key simply means to capture the keystroke that the user clicks on. Now, since you're brand new to programming, I do need to talk to you a little bit about something called keyboard focus. So we're going to click out of this for just a second. Notice here the calculator. So I'm going to put, let's put the calculator up, and let's put up the notepad, right? So here we have a notepad program. Keyboard focus means that, like, if I'm pressing keys on the keyboard and my notepad, this process or this program that's running in the computer, if it has keyboard focus, it means Windows is taking the data that's being typed in from the keyboard and is feeding it to this program. If I click on calculator, notice how the top here turned blue and this went gray, and that is in this particular setup for Windows, and that gets into the theme, okay, and the background and all of that, right? You guys are probably familiar with this, but just in case you're not, if I'm typing, let's say, numbers, and the calculator program has keyboard focus, the data from the keyboard goes to the calculator program. So here's the catch: if your program has keyboard focus, okay, then the data will be caught by the runtime engine, placed in a buffer, and when you use the in key string, it will read the information out of the buffer and feed it to you. All right. So effectively, when your program is running and your program has keyboard focus and the user types on the keyboard, you can get access to that data using this command, this in key string command. So it's going to, this situation here, it's going to say we're not going to wait on the user to enter information. So if there's no information, return a null string. And that null string means a string that has no characters in it. It's a zero length string. But if the user types something, this logic here allows you to have a bunch of different cases. Well, what if the key that the user hit is the escape key? Well, then what are we going to do? We're going to exit the loop. What if they hit the F1? Well, we're going to change the value of the speed control. This code here allows me to change the speed of the rows by pressing different function keys. So that's how this code here works. I'm not going to get too much into the switch statement and the end switch. This is, you can read about it. Just hit Control-Shift and click on it, and it will explain it to you. If you go to it in the manual, talks about it. Here gives you some examples, so you can learn more about how this branching logic actually works on the switch command in the manual. It's a little beyond the scope of in this video. So we're going to go ahead and move on. And let's come down here and let's talk about some of the variables that we're using. Now, I'm going to skip all the way down to this part right here, and what we're doing is we're creating X and Y position variables. All right, this is there's something called a parametric equation. All right, and so what we have here is we have a parametric equation that is creating an X value and a Y value, and that is what's computing the position of the rows on the screen over time. So back up to here, we're going to compute the time, and so we have a variable time. We also have how much are we going to advance time every time we go through the loop. So let me start with this whole code right here is what I call the main loop. The main loop, we're using a while, and all the way down here at the bottom, a when. And this is called a while when loop. And what it means is that while this value is non-zero, this loop is going to loop over and over and over and over and over. Okay? A while one loop is an infinite loop. It will never end because one is never going to be zero. So it's going to loop infinitely. You say, well, why would you ever want an infinite loop? Well, you want to have to be able to break out of it. We want the program to run until the user hits the escape key. Okay? So what happens in the escape key, we say exit the loop, and there's the command that breaks us out of this loop. All right, so that's why we can let this loop go infinite. All right, because we don't care. We want it just to run until the user hits the escape. All right, so every time it goes through every time it goes through the loop, it's going to advance time. And it's going to advance time by an amount based off the speed control, because this time advance is going to be a result of this equation here. And notice that this is an exponential equation. We're taking 2 to the power of whatever speed control divided by 2 is. So, for example, if we press the F12 key and set speed control equal to 12, then you're going to have 12 divided by 2, which is 6. And 2 to the 6th power is actually 64. So you're going to have a factor of 64 for the speed control 12. However, if let's say up here for speed control 2, right, it's going to be 2 divided by 2 is 1, and 2 to the power of 1 is simply 2. So you can see that every time you go through the loop, it's going to be 2 times 0.003, or to put this another way, it's going to be 0.006. That is going to be the amount of time that gets advanced each loop through. However, down here, it would get advanced 0.192. All right, so there's a huge difference, okay? It's not linear, and if you were to actually compute the values for each one of these and print them on a graph, you will see it is an exponential graph, and that is the reason why we call this an exponential speed controller. We're controlling the speed exponentially. That is setting the time advance so that every time it goes through the loop, it's advancing by that amount. So if we hit F12, every time through the loop, time is advancing by 0.192. If we have the speed control set at 1, every time through the loop, time is advancing by 0.006. Now let's look at this next thing called frequency control. Now, when you deal with sines and cosines, okay, the frequency of the sine wave can be controlled by the amount that is being divided by. So if you notice down here in these formulas, in this parametric equation, we are going to divide the time by whatever the setting, the current setting of the frequency control is. And we're going to vary the frequency control. And by doing this, it's going to create these beautiful loops that change over time. Okay, and that's the reason why the mathematical result of all this, you wind up with these roses dancing all over the screen, and it's not just a simple rose going around in a boring loop. Okay, and that's the reason why you wind up with these wild patterns, is because you're combining sine waves and mixing different waveforms on top of each other, and that's what's giving you this random, wild-looking over time dancing pattern. Okay, we're also, to talk about the computing of the row sizes. We're going to compute the size of the first rows, and we're going to use this formula here, which is going to take the base size, and that's where we talked about up here. The base size was, we set it at 50, and then it's going to take the variation, the amount we're willing to vary it by, which was the 200, right? And then we're going to multiply it by, and we're multiplying it by this here, which is going to give us this almost random, but it's actually following a mathematical progression from plus 200 to minus 200. And again, based off of the time and the frequency control inputs into this thing, you're going to get this size that varies over time. And so by mixing the size, having the size vary, and this is for rows 1, and rows 2, we're going to start with a base of whatever the size was computed for the first one. So we want to keep them fairly close to each other, but we also want to vary the size of the second rows a little bit, make it a little bit different than the size of the first rows, so that we can get the visual effect of one of the roses swirling around the other one. So you actually have the effect that these roses are moving independently but kind of tied together, but they're moving independently in 3 dimensions. And to achieve that effect, we're using this formula. We're tying the base size is tied to the first one, so that they appear, when they get really, really, really small, they appear to be really far away, and we want them to both be really far away at the same time. So that's the reason why we only vary the size of the second one a little bit with relation to how much the size of the first one gets varied. Moving on, so the amplitude is going to be one of the factors that gets computed in the actual position, and the amplitude, this is going to limit how much it can swing. Here we're having to say we want it to swing by 30% of the width and 20% of the height. That's the most we want it to swing, and this is for rows 1. So if you actually look, when it's running, let's go back and take a look at it. When it's running on the screen, I'm going to make it slow, the position that's actually doing it at, remember we're painting the entire rows on the screen, and the XY position is plotted as at over here on the rows. It's not the center of the rows, but it's the upper left hand corner of the rows. And if we come back and we take a look at this, the amplitude being the width and the height that can vary, we're limiting how far up and how far out either direction it can go. Okay, because remember, this is your center point. So on the x-axis, you got so much positive and so much negative, and on the y-axis, so much negative and then so much positive. So these variables here are limiting how far it can go out for the first rows, and then here for the second rows, we're just plugging in some limits. And by doing it this way, this is how much we're limiting it. But the way we use this on the second rows is we're computing the second rows, saying that we're going to start with wherever the first rows is actually at on the screen, and then we're going to have this amplitude, and we're going to vary off of that. And this is precisely why these two rows kind of stay together, because the second rows is keyed to the first rows' position, and then we vary it by this much difference off of the first row's position, which is also the reason why the second rows occasionally goes off the edge of the screen, because if the first rows goes close to the edge of the screen and then we allow the second rows to go an additional 200 pixels out, it can push it off the edge. Okay, so if you don't want the roses to go off the edge, you kind of have to change these formulas or create a formula that's going to take into consideration the pixel size of the screen and limit it further. I didn't want to go that far in this particular program, but you could add that in. So let's move down here. The next thing I want to talk about is subroutines. So remember, we already talked about subprograms, right? A subprogram starts with the keyword sub, and in this case it happens to be the captain subprogram, and it ends when you have the end sub for that program. And of course, your entire application terminates when program flow gets to the end sub of the captain subprogram. Now, a subroutine is something that exists within a subprogram. And the way you create those is with the go block command. So the go block command and the end go block defines a block of code that you can only get to with a go sub statement or a go to statement. And I'm not going to get into a go to statement for right now. So I'm just going to talk about subroutines. And what this allows us to do, instead of having all of this code up here and then paste it again here, we can use a subroutine and then simply go to that, and it executes this code until it hits a return statement. When it hits a return statement, it comes back up here and continues executing. Then it hits a go sub and it comes back down here again, executes. So it's kind of similar to a subprogram, but it's different. And the biggest difference is that a subroutine can only exist within a subprogram, and variables, all the local variables, are all part of the same subprogram. Remember, everything in a subprogram, all local variables are local to the subprogram they're used in. So a subroutine, all of these variables are the same, and something else. And that is that this go block, this block of code that has the name, it's a label, paint rows, so that this go sub can call this is local to this subprogram. That means a different subprogram could have a subroutine with the exact same name called paint rows. All right, and this go sub statement is only going to refer to the subroutine within this subprogram. All right, so it's kind of a critical concept to understand. All right, especially when you start working with multiple files in multiple subprograms. But it makes it really nice to use, because as you can see, we're using it here. And something else that we've done is we have another subroutine that is called this XOR rows with background. So what actually happens is, let me talk about program flow. First time it comes down here, it hits go sub paint rows. The paint rows starts executing, and if it hits this XOR with background, program flow drops down here, runs all of this, hits return, comes back, comes over here, hits this, comes down here, runs this. So you have what's called nested subroutines, that this subroutine is using another subroutine, and you can see how the way the program flow is going to work. And again, once it hits the return statement, it returns back up to here. All right, because this is a return statement within this subroutine, and you can nest these things up to like 64 levels deep. This would be considered 2 levels deep. This would be the first level, and this would be the second level. Let's actually talk about how the code works, because I got some interesting things going on here. The very first time through this paint rows subroutine, we have this if statement. If one shot, now this is what's called an array. We're saying if this variable happens to be off, then turn it on. And that's all it's going to do, right? With the if this condition is true, this code gets executed. All right, else means if this condition is not true, then the rest of this is going to get executed. That's the basic structure of the if, else, and if statement. If you've never used this type of logic and you are really a brand new programmer and doesn't understand the if-then statement, then I suggest you look at one of our other videos that talks about branching logic. What's happening here is that the very first time we're painting a rows on the screen, we don't have it on the screen yet, we just want to paint it on the screen. So we are just flipping this flag on and skipping over this because it doesn't get executed the very first time it's called for each rows. All right, and then we're going to paint the new rows image on the screen itself. This next time it's called, when the XY value gets changed through the next loop, the next time through the main loop, the XY position is going to change. And so what we need to do is we need to remove the previous painted image. All right, so we need to call this subroutine to remove it and then repaint it. So what's happening here is that the position, the first time through, we're setting the values. Here's the position we want to paint it at. We're calling, we're go-subbing, okay, which is running this subroutine. And this subroutine is painting it on the screen using special logic. And then we're remembering the positions. That's where it says old XPOS. So here's the first position of X. Is where we want to paint it on the screen at, but we're going to remember all this. So the very next time we call this, this logic right here can remove the previously painted rose image and then drop down and paint it again at the advanced position. So let me show you guys what happens if you happen to, I'm going to remark out this command here, which is the command that is causing it to remove the previously painted image. Watch what happens when we run this. And I'll go ahead and hit F12 and see we're painting it but not removing it, so you just wind up with a mess on the screen or a wild image. I don't know, somebody might want to say, hey, I want to create some effects doing something like that. Well, that's how you can do it. But if you actually just want to be able to see the rows, you want to remove the previously painted image. Now, I'm going to take out that remark indicator and reactivate that piece of the code. I'm going to show you something on this command, copy rectangle using XOR logic. Okay, if you're not familiar with XOR logic, I'm not going to get a whole lot into what it does, but if you XOR an image onto another image and put it there, and then you XOR it again, it will take it off. Okay, so there's a mathematical reason why that works, but the effect is that the very first time that this is run, it will paint the image on, and if you run it again with all of the settings identical, the XY position setting to be identical, the paint face happens to be, do we want to paint it, do we want to use the left facing rows or the right facing rows? So we have to, use the same image, right? And we also have to use the same size of the image, right? So if all these parameters are identical, the first time it's run through here, it paints that image onto the screen. Second time it's run on there, it removes the image from the screen because of the logic involved with the XOR, okay? So we're going to talk about how it's changing in the size, and I want to talk about that a little bit. And that is, notice the size of the source rectangle. Well, we've already showed you on the screen how big that rose is. So that rose exists. It's the whole source rectangle. You notice the rose is on a black background. That's because when you use XOR logic, since black is all zeros, you don't see that square black image and you only see the colored rows. Because when you XOR 0, nothing happens. It doesn't change the background at all, so it's invisible. And that's the reason why we're using a rose on a black background versus a rose on a white background. Because if that rose was on a white background, you'd have a white square going across the screen. We don't want that. We're defining, look over here, and notice the define target rectangle. This command, if we were to use this command, what it's actually doing is it's saying, okay, you have 5 parameters, and what it's actually doing is it's assigning these values, it's checking the values to make sure that they're legal values. And then if they are, it's assigning them to these variables. And they're called CB variables, right? But you don't have to use that. You can actually set the CB variables up directly, and that's what I'm doing in this code. As I'm saying, the target rectangle is going to be the display shield, right? So when this copy rectangle command gets executed, it's going to copy whichever, either the right or the left row's image, whichever one is being picked here, okay? And it's going to copy that onto the display shield using this XOR logic, but it's going to just copy it to the rectangle using stretching. So it's going to stretch that image or compress it, right? Either way. to the size of the rectangle. So here's, we're setting the target rectangle of the X position, the Y position, and notice here what we have going on. We're setting it to the X position. We want the display shield center plus wherever the X position is supposed to be at. Because remember, this is going to be run on different computers that have different size screens. So when we opened early when we were in the setup for this, we defined the value of the center point, right? We computed that and saved that to this variable. So that's the reason why no matter what monitor you run this on, no matter what size monitor you're running on, these roses are always going to dance around the center of your display shield because we've computed the center point. So we're taking the center point, we're adding the paint position that we want to paint relative to the center of the current display shield being used. So that's how we're defining where the X and Y position of this target rectangle is going to be. And then as far as the width and the height, because this rose is in a perfect square, if you look at the number of pixels of that image, it is a perfect square. So that's the reason why we're using the same, whatever paint size we're deciding, we just make it the same for both the width and the height. And remember, we said that that was going to vary by between a 50 by 50 to a 450 by 450. So that is being set here. And then what this one command here is doing, this copy rectangle, it's copying this image of this rose, it's adjusting the size based off of these parameters, right? And it's using XOR logic. So this is the command that's doing the most amount of work for you, okay? Because it's the command that's changing the size of the image and throwing it onto the screen and then removing it from the screen without damaging the background. It's doing all that, right? Yeah, the first time it gets called, the image gets painted. The second time, it gets erased. So that's it. And then we're at the end of the program. So we've now talked about all of the code and showed you guys all of the code, and it's not that complicated, right? I mean, once you start playing with this, even if you're 16, 17 years old, you've had an algebra class, you can actually look at this and say, hey, yeah, I understand this. I understand the concepts that are being used to create this. And what looks like it would be a monster of a program to try and create, like, wow, man, how do I create something that's going to do that with roses? And I mean, that would be very difficult to do. And all these it's not really that difficult. Okay, you understand a few key concepts. It becomes fairly easy and fun to code. So that's it for this video. Please go ahead and hit that subscribe button. If you want notifications of when we post new videos out, also hit the bell button. And by all means, give the video a thumbs up. That tells YouTube that people do like this video and does put this video up higher in the rankings so that other people can find it.